Hey guys, and welcome to 11.7a. I can translate a figure on the coordinate plane and describe it verbally with a map using transformation notation and with a vector. So we are starting a unit all about transformations, and a transformation is a change in the position, size, or shape of a figure. When we transform a figure, we create an image of the figure, where our original image is known as the pre-image. So the big idea basically is we're going to take shapes and we're going to change them. We're going to move them, we're going to flip them, rotate them, slide them, and we're also going to shrink them and enlarge them. So that's the big idea for this unit, is how can we change figures on the plane. So our first transformation is actually a translation. And a translation is basically a slide. And it will go a specific number of units in a specific direction, either left, right, up, or down in our coordinate plane. So a transformation actually maps all of the points in a figure in the same distance in the same direction. So for example, right here, we have a lovely transformation of our image, ABC, and the whole image ABC underwent a slide where it shifted to the right and down the same distance for each point. So a verbal description for this might be 2 units to the right and 4 units down. Mapping, we would say that our x value went right 2, that means we added 2 to our x value, and our y value shifted down 4, that means we subtract 4. So if we're moving right in the x direction, then we're adding units. If we're moving left, we're subtracting, because that lines up with our knowledge of the number line. Similarly, with our y values, if we're going up our coordinate plane, we're going to be adding values. And if we're going down our coordinate plane, we should be subtracting values. Now, another way to notate this is to say capital T for translation, and then in sub parentheses 2, -4. And just like with all of our points, we always list x then y. Well, our x changed in the +2 direction, and our y changed in the -4 direction. And our final way of notating this is vector notation. You're going to see this a lot in physics, guys, coming up here in the future. So vector notation is v with an arrow over it. That's v with an arrow. And then you use these triangular brackets, and then otherwise it's the same as the translation notation. We move 2 positive units in the x direction, -4 units in the y direction. So let's do some examples together. Here I've got a triangle and it has been shifted to the right and down. So let's take a look, I think, at point B and see what happens as we go from point B on 1 to B prime, our image of B. So B, we went 1, 2, 3, 4 units right, and then 1, 2 units down. So that means my verbal description is 4 units right, 2 units down. If we were to write the mapping notation, that's x comma y becomes, well, right is a positive change for x, so x +4, comma, down is a negative change for y, so y -2. My notation, it's T for translation, and then in a subscript, the x changed 4 units, and my y changed -2 units. And my vector notation is my v changed +4 units right, -2 units down. So now take a look at and back up here, you can see that every single point undergoes that same change. So here my A value went 4 right, 2 down, and my C value went 4 right, 2 down. Every single point maps the same distance and direction. So now let's take a look here. My original shape is down here. It's the one without the primes. It's the one without the little tick marks at the top. And so I want to look at point G, I think this time. I'm just choosing a random point. Well, G goes 2 right, and then straight up 4. So my verbal description is 2 units right, and then 4 units up. The mapping is that any x comma y value goes from xy to x plus 2, and up is a positive direction. Oh, I need to put that in a comma right there. X plus 2, comma, y plus 4 this time because we're going up. My notation, T for translation, positive 2 units in the x direction, positive 4 units in the y direction. And my vector, v, my change is positive 2 units in x, 4 units in y. So those are the 4 ways to write how we translate something. So now I'm going to do 2 different translations, and I'm going to do them myself. My first one is T62. Well, T62 means 6 units x direction, the positive is going to be right, and 2 units in the y direction is going to be up. So let's take each point and do that. I'm going to start with point O. We're going to go 6 right, 1, 2, 3, 4, 5, 6, and ends up here. And then up 2, 1, 2. That right there is my final point. And so we're going to call him O prime. N is going to go 6 right, 1, 2, 3, 4, 5, 6, up 2 here. So this guy here is N prime. And M is going to go 6 right, 2 up. Right here is M prime. So I am going to do that guy right there. And now let's look at this one. This one right here says x minus 1. That means we're going 1 unit in the negative direction for x is left. And then y minus 2 means 2 units and the negative direction for y is down. And so let's do this. I'm going to start with O. I go 1 unit left, 2 units down. Right here, I'm going to call him O double prime, since that's my second translation, and I don't want to get it confused with this first guy. N, we're going to go 1 left, 2 down, right here. N double prime. And then M, we're going to go 1, did I do that? Yeah, 1 unit to the left, 2 down, right here. M double prime. So we connect. Ta-da! Not too bad, right, guys? All right, so quick summary of our properties. If you notice, distance-wise, the lengths of all my segments stay the same. My orientation is the same. My lettering order is preserved for each of these, so we're not doing anything weird there. All of my angle measures are the same because we actually create a congruent image. Linearity, the figure maintains all of its parallelism, perpendicularity, collinearity, and midpoints. Nothing there changes. And it actually produces a congruent image as an image congruent to the pre-image, and therefore is also similar because all congruent shapes are also similar. So that's our summary of translated properties. Go ahead, guys, and take a look at the MML.